Hi guys, I have my balance in front again, and we're going to talk a little bit more about equations. It should be pretty easy. So today the rundown will be the teaching of the equations, just addition, a little bit of subtraction, same as yesterday pretty much. And then there's a split screen review, not many questions, and you'll just put one on one side and one on the other. Just put it on YouTube and put it in Shobi. Do a problem, watch the answers, do a problem, watch the answers. Or if you want to do the whole sheet and then watch the answers on the video, that's how you see if you've done your practice correctly. And then your assignment's going to be pretty short too. So again, pretty short. I'll try to be quick with the instruction. Not too bad, but make sure you pay close attention, because once you see it, it's really not bad at all. Just as I said yesterday, the balance is the same as an equation. It means that this side of a balance has to be the same as this side. Put a little equal sign in here, put it there to get the idea that whatever's on each side, they have to be the same. Okay, so you say, yeah, okay, that makes sense, duh. But to make that the same, sometimes we don't know what something is. And that's how we use this balance idea. And that's really algebra. And when we use algebra, we're talking about variables. And we use x a lot. And this would be x as a variable. We don't know what it stands for. It can stand for anything. It could be 10 or 20. Whatever the case is, it varies. It depends on the situation. So if I say that this is x, I'm not in balance because it doesn't show what it is on the other part. So the equal side really means what's on one side is the same. And that's my gremlin guy went down. X equals 5. So if x equals 5, I'd have to put 5 on this side. Then there would have to be 5 in this side to make it equal. All right, that's what the equal side means, and that's the idea of the balance. Whatever's on one side has to equal same as the ones on the other side. Now in this case, there would be x plus 2 equals 5. Now I have the x here, and if I put that on one side, that would be the x plus 2. So that means I have to have 2 more. X plus 2 is going to equal 5. I'm out of balance. Well, to equal 5, I'd have to have 5 over here. So I put 5 over there, and now I'm in balance. So x plus 2 equals 5 is an equation. It works, it's fine. It's in balance. Now, I need to figure out what x is. Yes, I know you can figure that out in your head. It's pretty easy, and that's what we did for the assignment yesterday. But you are, to prove it, and there's some more difficult ones, but to prove this, or to find it out, we want to get x by itself. And to get x by itself, we have to get rid of these 2. So we want the x by itself. So I'm going to get rid of these 2. So I'm going to take 2 away from this side. I'm out of balance. So if I take 2 away from this side, to keep it back in balance, I better take 2 away from this side. And now I'm in balance. So x equals 3. So that means there would be 3 in the x. So that looks like this on paper. So I have x plus 2 equals 5. I need to take 2 of these away because I want to get x by itself. So I'm going to subtract 2 from this side. It says x plus 2. I have to get rid of these 2. So it's really, I'm just kind of doing the opposite. It's plus, I'm going to subtract 2 of them. So I take these away, and then that becomes x plus 0. It's going to equal 5. It doesn't equal 5. It's not there. I don't need to write the 0. That's just identity property. I can leave the x by itself. So x equals, but it doesn't equal 5. I'm not right. On this side of the equal sign, I took 2 away. I have to do the exact same thing to the other side. So to keep the equation balanced, what you do to one side, you have to do the exact same thing to the other side. So I have to take 2 away from this side, 2 away, and then I'm in balance, so x equals 3, and x is 3. Would be in balance. Okay, not a hard concept. Not a hard concept. And this is how you'd show your work for this. For this one, same concept. X plus 4 equals 6. I already have it set up. So x plus 4 equals 6. X is here. We don't know what it is. There's some chips in there. We don't know. X, the variable. Plus 4. I have 4 over here, then I have 6 over here. I need to get this x by itself. It's called isolating the variable. I want to isolate the variable to get the x by itself. So what do I have to do? Get rid of this 4. Get rid of these 4. How am I going to get rid of these 4? I'm going to take the 4 away. So I'm going to take these 4 off. And on paper, you would show that by subtracting 4. So I take 4 away. I'm out of balance. My equal sign is supposed to be balanced. It's not. I took 4 away from this side. What do I have to do to the other side? I have to take 4 away from that side. And if I take 4 away from that side, I end up balanced again, and I'm going to end up with 2. So know that it's going to be 2. So x here, because this is 0, I don't need to write x plus 0, identity property, doesn't matter, I don't have to write that, equals 6 minus 4 is 2. X equals 2, and we know, we proved it, that x equals 2. I'll do this one super fast. X plus 1 equals 7. X plus 1 equals 7. What do? I need to take this 1 away from this side. Take the 1 away from this side. It's plus 1. You subtract 1. Let's get the opposite. Take it away. I'm not in balance anymore. I need to take 1 away from this side. Now I get x is going to be the same as 6, because x equals 6, because 7 minus 1 is 6. There's 6 in there. For subtraction, it's just a little bit different, and the balance gets a little confusing on it, but it's really not that bad. This would be like x minus 2 equals 5. Well, notice how I'm not in balance. I am not in balance. And the reason I'm not in balance is because what's in x, I have 2 extra ones in there. Because I'd have to take 2 of them out to get this. So I'd have to take 2, because x minus 2, take 2 away from x, would give me a 5. Well, that's confusing. Okay, so if I take 2 away from the x, that would give 5. That's what x minus 2, take 2 away from x is 5. But that's not the case in there. I need to get x by itself. I can't just take 2 out of the x. So what I have to do is, I know that there's x's, this is 2 less than what's in x. Okay, and I just add the 2 over here. Because it told me if I took 2 out of this x, it would be 5. So what if I put 2 over on this side? Then I'm in balance. And the trick to that is, I'm just doing the opposite. If it's x minus 2, if you add 2, they get x by itself, because it's x minus. You're taking away, you're doing the opposite. You just do the opposite. So x minus 2, you're adding 2. So minus 2 and add 2, that equals 0. So then x is 0. But then if I added 2 to this side, it's already there. I'd have to add 2 to this side. And that's how it becomes 7. So really I'm adding 2 to this side because there's 2 that are missing, putting 2 back. And then I'm putting here. And I think the big trick is, the big secret is, if it's x minus 2, you do the opposite. You're going to add 2. And you have to add 2 on this side. And that's how you figure it out. So x is 7, and yes, we know it's 7. So when you do the addition, x plus 4 equals 8, you're subtracting, because it's plus 4, you're going to subtract from each side. You get x equals 4. But then if you do subtraction, x minus 3 equals 2. To get this minus 3 away, you just do the opposite and add 3. So x equals 5. I'm going to do a couple examples on the board, and then your split screen are just examples just like this. I'll show you, and you have to show your work, and this is how you show your work. This part right here. That's how you show your work. You have to have those parts. You can't just write down what x equals. You have to have what you did to each side. I'll show you those on the board, and then split screen pretty quick, and then your assignment is just with these similar ones, probably 6 questions. Just make sure you show the work. For x plus 3 equals 5, you would take 3 away from each side. This is plus 3, you have to subtract 3 to get the x by itself. Do the same thing to the other side. X equals 2, because 5 minus 3 is 2. That's how you would show your work. So that's a complete problem. X plus 5 equals 9. Because it's plus 5, you do the opposite, subtract 5, have to do the same thing to each side. If you do one thing to one side, you have to do the exact same thing to the other. This becomes 0, x equals 4. That is how you show your work. X plus 9 equals 14. You need to get rid of this 9, so you subtract 9. You have to do the exact same thing to the other side. You get x equals 5. That's your exact same work, and you can always check to see if you're right. Does 5 plus 9 equals 14? Yes. Does 4 plus 5 equals 9? Yes. Does 2 plus 3 equal 5? Yes. Can you have a question where 8 equals c plus 2? Yeah, it doesn't matter which side of the equal sign it is. They both just have to be the same. So c plus 2, I need to get rid of this 2. I'll subtract 2. Subtract 2 from that side. I get c by itself because that's equal 0. And that's 6. 6 equals c. Perfectly fine to do it that way. 16 equals m plus 5. Need to get rid of that 5. Subtract 5 from that side. Subtract 5 from that side. That becomes 0. We can just keep that as m. And plus 0 is the same as m. Then it's 16 minus 5, which is 11. So m equals 11. Checking it. 11 plus 5 is 16. So on this one, 12 equals 5 plus x. Can you do it that way? Yes, yes, yes. You just need to get rid of this 5. Now, is it adding a 5? Is it subtracting? Well, it's a positive number. You can just subtract 5 to get rid of that one. So that becomes 0. So that's by itself. We isolated the variable. 12 minus 5 is 7. Is 5 plus 7 12? Yes, it is. And that is how you show your work for each one. For subtraction ones, similar. X minus 3 equals 4. Well, get rid of this minus 3. You just do the opposite, so you add 3 to it. So a minus 3, take away 3, you add 3. That becomes like a minus 3 plus 3 is 0. And that makes the x by itself. If you add 3 to that side, you have to add 3 to this side, you get x equals 7. And that's how you show your work. X minus 9 equals 2. Get rid of the minus 9. You have to add the 9. It's like the opposite. So subtract 9, add the 9 to it, gets it by itself, the x by itself. Add a 9 to this side, I get x equals 11. That's how you show your work. And you could have 4 equals c minus 10. What do? I try to get rid of this minus 10. I add 10 to it. Add 10 to that side. The c is by itself because that would be like 0. And c equals 14. Checking your answer. 14 minus 10 does equal 4. That's how you show your work.